Hello. To build upon the previous video, I'm going to provide you with an example of the potential of R to generate more elaborate plots. To illustrate this process within RStudio, let's open the script file 10 fancyplot.r. Due to the relative complexity of this example and my desire to keep this video relatively brief, I will not explain all of the individual arguments used in each command. Instead, I will just explain the general purpose of each command and execute them one at a time. This will illustrate that the generation of the graph is effectively the laying down of a series of layers, one on top of another, gradually construct the final image. As in the previous video, we will start with the dev.auth command, clear any prior graphs. We begin with the par command, where par is short for parameters, as in graphical parameters. In this example, these parameters include background color, margins, colors for labels and axes, label fonts, scaling factors for labels, and the types of ticks used on the axes. Execute this command and, well, it's actually kind of anticlimactic. Since you haven't actually specified any data to graph, executing this command does not yet generate anything in the bottom right pane. The second command uses plot, which I introduced in the previous video. I set the first argument, which is the points to be plotted, to 0, so that for the time being, no data points are plotted. However, with the remaining arguments, I set the minimum and maximum values for the x and y axes, the type of plot, the orientation of the axis labels, the main title, the labels for the respective axes, and the aspect ratio of the graph. Upon executing this command, we get a basic idea of what the graph will look like, but without any points yet. Appropriately, the points next get added using the points command. This is a relatively short command with just 4 arguments: the x-coordinates, the y-coordinates, the type of symbols used for the points, which is defined in such a way that depending upon the number of cylinders in the car, you will see a different symbol, and the color for the symbols, which is green. Upon executing this command, you will see that the plot looks as it did before, but it now includes points. That's great, except the viewer has no way of telling what is represented by the 3 different symbols used for the points. So, it's time to create a legend, and the command for creating a legend is called, you guessed it, legend. When defining the arguments for the legend command, start by indicating where to place it. I've planted it in the upper left part of the plot, where it's unlikely to block any points. Then, define the types of points in the legend, their color, and their corresponding labels. Provide the background color for the box and the text color, preferably contrasting colors that will make it easy to read the text. Execute the legend command and voila! You've now got yourself a legend. Okay, now we are definitely on a roll. Let's add a trend line to this graph. This involves 2 commands. The first uses the LM command, which stands for linear model, and requires 2 arguments. The first states that you are plotting horsepower as a function of engine displacement. As in an example from a previous video, you are once again using that squiggly tilde character to mean as a function of. The second argument tells where to get the data, from the MTCars dataset. After assigning this linear model to an object named trend, plot it using the abline command. I'm not sure why abline is called abline, but it's pretty easy to use. Aside from indicating the linear model that's being drawn, just define the type of line, for example, solid, dashed, dotted, etc., and the line color. Execute those last 2 commands, and you now have a handsome trend line. Now, let's draw attention to the points corresponding to the cars with the highest horsepower and the largest engine displacements. You'll begin by using the subset command that you learned in a previous video. If you look at the example in the source pane, you will see that 2 criteria, either highest horsepower or largest engine displacement, are provided as arguments for subset. Note that these are separated by a pipe character meaning OR. So, in this case, the subset command will capture records that meet either of those criteria. And, as long as we're on the subject of nomenclature, here's another case where it's important to use the double equal sign. Now, use the points command to replot those 2 points in a way that stands out from the other points. use the text command to place labels next to the points. As a crowning touch, let's add some grid lines using, of course, the grid command. For our example, we start by indicating that we will align with the existing tick marks on the axes, after which we specify the color, type, and thickness of the lines. So, as opposed to the fairly rudimentary examples from the previous video, this gives you an idea of what you can do with a data plot if you pull out the stops. Remember, if you want, you can export your image using the Export button on the Plots tab of the bottom right pane. To test your understanding of the content of this video, you might try the following. Number 1, change the background color of the legend. 2, change the line type for the trend line. And 3, change the label for the x-axis from displacement to displacement cubic inches, where cubic inches is in parentheses. During this video, I've made reference to arguments for indicating line types, colors, and symbols. A variety of sources are available online for how to define these arguments. Some examples of websites include the following. In the next video, I will briefly discuss commands used for working with text.